Hi friends, welcome to my channel Interesting Engineering.
In our video today, we are going to discuss about range extension of voltmeter. As I said earlier, the ammeters and voltmeters are instruments which operates based on the deflecting torque developed due to the current flowing through the coil. So in this case, the voltmeters have a limitation in the amount of current that can flow through the coil. So it can measure, in general any voltmeter can measure only up to 100 millivolts. So if we want to measure voltage ranges greater than this 100 millivolts, here we need to introduce a special arrangement through which we can even measure greater values of voltages. So for that we go for a multiplier, that is here we go for another resistance. So that resistance is connected in series with the meter. So this resistor is made of manganese or constantan, and this resistor is called the multiplier resistance. So to extend the range, a series resistance is used to limit the current through the meter. So when we go beyond the limit, the meter gets damaged. So to overcome this problem, we go for a resistor connected in series with the meter. So here, since it is a series circuit, the same voltage, the same current flows through the circuit, whereas there occurs difference in potential drop across every element. Since these two are connected in series, the amount of voltage entering here gets dropped. There occurs potential drop across this resistance as well as the meter. Based on this concept, we are going to derive the equation for finding out the value of multiplier resistance. So here we have a meter, and this meter is connected in series with the multiplier resistance to limit the current through this meter. So if we want to measure more than 100 millivolts, we need to connect a resistance in series with the meter. So the current through this both resistor and the meter remains the same, but there occurs voltage drop, potential drop across these two elements. So by means of voltage division rule, we can able to find out the voltage across this meter by Vm equal to total voltage into opposite resistance, series resistance Rm divided by Rs plus Rm. So I am bringing this Rs plus Rm to the other side. So Rs plus Rm equal to V by Vm into Rm. So this Vm I am bringing here. So Vm into Rs plus Vm into Rm is equal to Vrm. So we need the value of shunt resistance. So I am keeping this Rs term in one side and bringing all other terms to the other side. So Vm Rs is equal to Vrm minus Vm Rm. So that is V minus Vm into Rm. And this Vm I am bringing to the other side. So V by Vm into Rm minus Vm by Vm into Rm. Vm by Vm is 1. So it is V by Vm Rm minus Rm. So now I am replacing this V by Vm by the multiplier resistance, that is mv minus 1 into Rm. So Rs is nothing but Rs will be equal to mv minus 1 into Rm. So by means of this equation, we can able to find out the value of series resistance that has to be connected in series with the meter resistance, so that we can able to measure higher values of voltages. So as I said earlier, we go for manganese material, that is the series resistance is made of manganese when it is used for DC values measurement, and it is made of constantan when it is used for AC measurement. So what should be the characteristic? Let's see about the features that the series resistance should have, so that it doesn't introduce any change in the instrument. So the resistance should not change with time, and variation of resistance with temperature should always be minimum. So any resistor that is used as the series resistance should satisfy these two conditions. That is, for every time period there should not be any change in resistance, and with when the temperature changes, the variation of resistance should always be minimum. So when a resistor satisfies these two conditions, it is used as the multiplier resistor, and it is connected in series with the meter so that it can even measure higher values of voltages. So that's about how to extend the range of voltmeter. So general voltmeter can measure up to 100 millivolts. It's due to two main factors, that is the weight constraint of the moving coil and the spring arrangement used, the current through the spring arrangement. So because of these two factors, it can withstand only up to 100 millivolts. Beyond this range, if we want to measure higher values of voltages, we go for series resistance, that is the resistance connected in series with the meter. So that resistor is made of manganese or constantan, and that resistor should satisfy two main conditions, that is its resistance should not change with time, and its resistance should variation with respect to time should always be minimum. These are the two factors that we have to consider. Okay, and then we shall see about the voltage sensitivity. So normally when we make use of a voltmeter, we go for voltage sensitivity, that is the maximum deflection for every current variation, that is SV. Voltage sensitivity is denoted by SV, and it is equal to 1 by IFS. So IFS is nothing but full scale deflection current. So normally we can represent the current as Vm by Rm. So it is 1 by Vm by Rm, and it is equal to, I am bringing this Rm to the numerator, so it will be Rm by Vm. So voltage sensitivity is equal to Rm by Vm, and its unit is, since R is in the numerator, its unit is ohm, V is in the denominator, its unit is volt. So voltage sensitivity, the unit of voltage sensitivity will be ohm per volts, or ohm volts inverse. So now I am going to write down the RS equation in terms of voltage sensitivity. So normally we have two resistors in series, RS and RM. So the entire voltage enters into these two so here V is equal to Im into Rs plus Im into Rm. So we need the value of Rs. So I am keeping this Im into Rs in one side and bringing all other terms to the other side. So it is V minus Im into Rm is equal to Im into Rs. So in the next step, I am bringing this Im to the other denominator. So it will be V by Im minus Im by Im gets cancelled out. So it is Rm equal to Rs. So 1 by Im is always we have seen it is SV, that is voltage sensitivity. So we can write it as Rs is equal to V by Im, that is V into SV minus Rm. So the series resistance can be written in terms of voltage sensitivity as Rs is equal to V into SV minus Rm. By means of these two equations, we can able to design the value of the series resistance that has to be connected in series with the meter to have a maximum value of voltage that can be measured. Okay, so this is about how to extend the range of voltmeter, and we need to see how to measure different values of voltages using a single meter. So by making use of a single meter, we can even measure multiple values of voltages by means of connecting different values of resistances. So we have to connect the multiplier resistance in series with the meter. So different values of multiplier resistors are connected, and switch and the meter is connected with the multiplier resistance by means of a switch. So this based on the switch contact of this based on the position of this switch contact, we can able to achieve different voltage levels. So by means of this, we can able to measure different values of voltages by means of this single meter. So that's called a multi-range voltmeter, and by this multi-range voltmeter we can have multiple values of voltage that can be measured using this meter. But a drawback here is, here we make use of different resistors, go for different resistors that may increase the cost of the instrument. So to eliminate that problem, we go for this potential divider arrangement, where we have a single resistor directly connected in series with the meter. So this single resistor will have different tappings, so the switch will be in contact at different tappings. So depending upon the position of the switch at different tapping levels, we can able to have different values of voltages. So by means of which we can able to measure multiple values of voltage by using a single instrument. So this is about a range extension of voltmeter. So in the range extension, we go for a series resistance made of either constantin or manganese, and this series resistance value we can able to find out using these two equations: Rs equal to Mv minus 1 into Rm, and Rs equal to Vsv minus Rm. By means of these two equations, we can able to connect a resistor in series with the meter, so that any damage to this meter can be avoided while measuring large values of voltage. So this is about range extension of a voltmeter, and in our next video we shall see about how to calibrate a meter and voltmeter. So for more videos, keep watching. Please subscribe and share. Thanks for watching.